Good morning, everyone. Welcome back, and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the science and technology channel.
Yes, and we are talking about a health topic today. Been doing that a lot lately. This one has to do with people that are getting older and need a little help to kind of rejuvenate. So here we go. This is a cool story.
A sulfur-containing compound may shield one of the body's most important muscle repair signals from the chemical damage that drives age-related decline. Man, I'm feeling it right now, and I'm only 58. I'm feeling it. Aging muscles may not lose the signals needed for repair. Instead, those signals may remain in place but become chemically damaged and unable to do their jobs. Researchers have now identified a sulfur-containing compound that appears to protect one crucial repair protein while also making it bind more strongly to muscle stem cells. Would you like to know more?
The discovery could eventually inform new approaches to muscle loss caused by aging, inactivity, or extended bed rest, which all go along with aging, right? For now, however, the findings are preliminary and come primarily from laboratory experiments and a mouse model. We love the mice, and not human clinical trials yet. Skeletal muscle is particularly vulnerable to aging. It can gradually lose strength and flexibility as scar tissue and fat accumulate between its fibers. Fast twitch fibers, which generate the explosive force needed to rise quickly, catch a fall, or climb stairs, are often affected most severely. So, yeah, been dealing with a lot of that lately. Not me personally so much, but family members. So,
A team led by Professor Ryuichi Tatsumi at the Kyushu University's Faculty of Agriculture investigated a possible molecular cause of this decline. Their study, published July 24th of this year in Scientific Reports, focused on hepatocyte growth factor, or HGF. Despite its name, HGF is not limited to the liver. In skeletal muscle, it helps launch the earliest stage of repair by activating satellite cells, the resident stem cells positioned alongside muscle fibers. This is not to be confused with human growth hormone. This is HGF.
and what is eight? What is that? HGM? No,
HGH. Yeah, that's like the
HGH.
Barry Bonds
Right,
drug.
right.
Makes you get big. Yeah.
Yeah. HGF is normally stored within the extracellular matrix, the supportive material surrounding those fibers. Exercise, injury, or other mechanical stimulation releases it. The protein then connects with c-Met receptors on dormant satellite cells, prompting them to awaken, multiply, mature, and help repair or enlarge muscle fibers. Okay.
That sounds right. That sounds right.
Yeah.
This system becomes less reliable with age. Tatsumi's team previously found that HGF can undergo nitration, a chemical modification driven by reactive molecules in the body. During this process, nitro groups are added to two locations on the protein, Y198 and Y250.
Those sites are especially important because they form part of the region that HGF uses to bind c-Met. Uh, Nitration can alter that region enough to weaken or prevent the connection. The protein may still be present, but it can no longer deliver its repair signal effectively.
The damage appears to accumulate particularly in fast twitch muscle fibers, potentially helping explain why these powerful fibers are preferentially lost during aging. HGF also helps restrain cells involved in fibrosis and fat accumulation, so disabling the protein could contribute to several features of aging muscle at once.
The researchers tested two sulfur-based antioxidants, glutathione trisulfide, or GSSSG, and lipoic acid trisulfide, or LASSS. Both belong to a family of compounds called trisulfides, which contain three consecutively connected sulfur atoms. Their unusual chemistry allows them to participate in redox or redo reactions, redox,
Yeah.
making them of growing interest in pharmaceutical research.
Yeah, so I take our lipoic acid, and this is lipoic acid trisulfide. Interesting.
And what do
As
you
a
take that?
supplement.
What do you take that for? Pain?
No, man, I can't tell you right now.
You
It's
just
just on
take
the
it
list
because
of recommended.
you just take it because the doctor told you to take it.
What? Not a doctor. Well, yeah, Dr. Mark Hyman on the eat fat, get thin type diet.
Gotcha.
Well, yeah. Initial experiments produced a partial success. Both compounds suppressed nitration at Y198 and Y250, but neither fully restored HGF's ability to bind CMET. The team then increased the molar ratio, well, now we're talking dentistry, of HGF to trisulfide from 1 to 4,000 to 1 to 8,000, so they doubled it.
At the higher ratio, LASSS did something unexpected. HGF exposed to the compound bound to CMET with more than twice the affinity of untreated HGF. It also became more resistant to the loss of function caused by nitration, particularly at Y98. GSSSG did not produce the same enhancement. Okay.
The findings suggest that LASSS may work through more than its antioxidant activity. According to the researchers, it appears to interact directly with HGF and alter the protein's local structure without disrupting its ability to activate satellite cells or support their growth and development.
The team next examined whether the protective effect would appear in living muscle. They used mice subjected to tail suspension. What is that? That's weird. An established model of muscle atrophy caused by unloading and inactivity.
I think tail suspension is something having to do with muscle atrophy caused by unloading and inactivity. What do you think?
I mean, I'm trying to envision these mice being attached to something by their tails and hanging for long periods of time, which might cause them to say animal cruelty, but whatever. What do I know?
Mice pre-treated with LASSS developed significantly less HGF nitration than untreated animals. GSSSG again failed to provide the same protection, supporting the idea that the effect depends on the specific interaction between LASSS and HGF rather than antioxidant strength alone.
The research points towards a different way of addressing muscle decline. Instead of replacing a missing growth factor, a future treatment might protect an existing repair signal from age-related damage and improve its ability to activate muscle stem cells. Okay?
Because comparable forms of HGF occur in humans and other mammals, the researchers believe the mechanism could eventually have implications for people as well as companion animals such as cats and dogs, helping preserve mobility, independence, and quality of life during aging or prolonged activity.
Okay.
I know my cat's getting up there, and I'm starting to worry about how long he's got left. He's 13, 14.
That's a long life for a cat.
Yeah.
And I've seen the way you treat your cat. He found a good home. So anyway.
All right, folks. Thanks for joining us. We'll catch you this afternoon.
See you this afternoon. Take care and have a good one. Thanks.